Okay. So now we can formally get started. And all my lessons, I have a full text version of the lesson, which has, that is kind of intended for people to follow along on their own. So if you click on that, it's got all the text, everything in it, as well as the code and the output in an HTML page. And the slides are what I'm going to be presenting off of today, just a more abbreviated version on slides. So that's what I'll be going through today. I'll go ahead and close this one so I don't get confused. And there is a worksheet, which is basically a code script with some blank spaces in it that we're going to fill in as we go. But you don't need to download that right now, because for today, I've given you all access to a demo R server that has everything installed, all the example data we're going to be working with, plus the worksheet already on it. So who has already joined that workspace with the link in the email that I sent out before the class? Did you all get that? Okay. Yes. Well, we'll go through that. Okay. So, yes, let's get everyone set up. So in the email, you should have had an invitation link to the Posit Cloud. So did everyone get that invitation link?
Yes.
Okay. So go ahead and go to that invitation link and then create an account on there. And then once you create an account, you should get to this page. Something looks like this, and you'll have well, you won't have as many as me, but we have this data viz basics March 2024 should appear on the left side. So let's get everybody up to that point real quick. So I can go around and help, and hopefully Grant can help out as well if people are not at that point yet.
Is it okay to do it locally?
Yes, yeah, that is fine. The only thing you're gonna need to do, yeah, if you have R Studio on your own, just go to the this. The only thing you're gonna need is this worksheet here. So just get that. That's all you're gonna need.
Okay.
Yep. The data are on a URL, so you can yeah, that's all. As long as you have ggplot2 package installed on your R. Do you have that? Or okay, great. So as long as you have that, all you need is a worksheet.
Okay.
Yep. Yep. Good morning. Okay. Yes, so there's breakfast is here, and then the beginners class is over there.
Okay.
See that door that's
They also
open?
have that too.
No, this is it. So go get your food. Yes, please do.
I'm in there, make it.
All right.
Beginner's class, you would say that. I don't, that doesn't mean I'm not remembering.
Yes, there you go. Okay.
We don't need a password.
Yeah, you have to create an account, so you have to make a password. Yep. You can use any email address you want. It doesn't matter. So let's yes, for those of you just getting here, let's see. So you have already have a Posit account from last time.
Yes, I logged into it, still works.
And so yes, and you'll need to join
He's in there already.
okay, you already have okay, great. So yeah, yep. And how about you, Patrick? You already have R locally, so you don't really need to use the demo version. You could just
No, I have it on my.
yep, so you're good there. So all
Yeah, I think
all that you will need then to follow along.
All the time. You had a couple other packages that I wasn't familiar with, so let's see.
Yes, well, yeah, we're the really only one you need is ggplot2. The other ones are just, I have some examples at the end with some add-on packages for it, but so yeah, Patrick, all you're gonna need to do is get this worksheet, which is like the code that we're gonna be going through if you want that. So you need to go to the worksheet you can get off of this website. Hopefully you can read that, usda-ree-ars.github.io/SEA stats. That's the URL. I think I have it written bigger at the top here. Yep, this is the site that you have to go to get the worksheet.
Right.
Okay, so how are we doing?
I can't find the word.
Okay, yes, go to the ggplot link there. Yep, yep, and there's,
Oh, perfect.
yep. Okay, are they all good over there?
Yeah.
Okay, great. James already set up and Patrick has it on his own, so we're all set. Okay. Okay, so now once you are in Posit Cloud, you're going to go to this Data Viz Basics workspace, make sure that's selected. And then you're going to go to New Project up here, okay? So everybody should, yeah, it should say Data Viz Basics March 2024 up there. Make sure that is selected. And then go to New Project and New RStudio Project. Click on that and it will do some things and it'll pull up a RStudio basically instance of RStudio that has everything we need right there. And so this is basically, this is only a demo server. It's only for the lesson purposes. Later, if you want to do this on your own with your own data, you're going to need to install stuff on your own laptop. But I didn't want to spend a lot of class time dealing with that. So this is only for the demo purposes. Don't upload your own data to this since it's not a secure, especially if you're a federal employee, it's not a secure server where, yeah. So that's the only thing to be aware of there. So I'll wait until everybody is good with that. And meanwhile, I'll start to present off these slides. So I'm going to be switching back and forth between the slides and the code. And let me actually make this a little bit bigger so that people can see. Let's see, I guess I'll just, if you make it too big, then it doesn't fit enough text on the screen anymore. Hopefully that's a good compromise. Okay. So yes, the lesson today, we're going to be doing some basic data visualization stuff using the ggplot2 plotting package in R. So basically, just to give a little bit of background, R being a statistical programming language that's been around since about the turn of the millennium or so, that was developed by some statisticians in New Zealand and has since kind of caught on in the statistics field, also kind of data science, and you know, a lot of fields are now using R. And then about 2008 or so, this guy named Hadley Wickham, for his PhD dissertation, wrote this package called ggplot. And that was kind of how now he's kind of like a celebrity in the R world. Everybody tries to get his autograph whenever they see him giving a talk and stuff like that. He has a lot of fanboys and fangirls out there. But this is kind of what was his original claim to fame, was the ggplot2 package, because it is a much more versatile and more featured plotting package than the plotting functions in base R. So I use it for all the figures that I make for publications and presentations and stuff like that. Pretty much always, with some exceptions, use ggplot. But now, basically, Hadley Wickham then, you know, R is open source free software. Hadley Wickham, being more business minded, kind of like monetized it by starting his own company, which was originally called RStudio, is now called Posit. They are the ones who make this Posit Cloud server and RStudio software itself. And so now he has a bunch of in-house people like working on ggplot. So it's sort of like how, you know, Linux was open source, but then Red Hat like formed a company to like make lots of money off of it. That's what he's trying to do with R on a slightly smaller scale. Anyway, just you might not care about that, but that's just a little background for you. And ggplot is nice because you can make real quick plots with a little bit of code for just exploring the data, and has lots of features you can use to make sort of manuscript publication worthy graphics. Now, it will be helpful in this lesson if you have a little bit of basic knowledge about R and how R syntax works, like if you know what a function is, what a data frame is, and that kind of thing. Of course, if you don't, that's okay. You can still follow along more or less. Please do ask questions as we go. Yes, that's kind of like the semi-prerequisite. I just already went over this. You know where to get the full text version that you can follow along with later. And the worksheet, I'll open, actually, yeah, let's go ahead and open up the worksheet. So if you go to your Posit Cloud, you should see this Files tab up in the lower right hand. If it's not, just click on Files. Then it has Data Viz Basics Worksheet.r. Just click on that. Once you click on that, a new window pane will pop up, which has R code in it. And you can see it's not complete R code. Sometimes there's 3 dots here and there. And this, this is not my original idea, but when I was a kind of like data science instructor at my last job, that's how we always had all our lessons set up this way, because if you have to just copy and paste code, you just do it blindly and don't really know what you're doing. If I give you no code, you have to type it all in yourself. There's a lot of opportunity for error, and people get stuck on stuff and fall behind. So a good compromise is to kind of give you most of it and have a little bit of blanks for you to fill in, so that you can have a little bit of that muscle memory of having your fingers type it in, but not all of it. So that's how we're going to do it. Yes. So anytime you see 3 dots, that's where you'll have to delete those and replace it with something else. But it's all the code is in the text version of the lesson as well. So you just have to, like, if you ever get stuck and don't have time to copy everything down, you can just copy and paste it from here. The complete code is all here. So that's just FYI. Any questions on the logistical aspects? I always like to start by giving an idea of what the learning objectives are going to be. So I'll give you a very brief background of Grammar of Graphics, which is the framework that ggplot, that's what GG stands for, uses. You'll understand that hopefully soon. We'll learn about how to take variables in our data and map them to variables, to aspects of a plot. We're going to make a bunch of different kinds of plots that you might see in scientific presentations, like scatter plots, box plots, histograms, density, and bar plots. We're going to also do some sort of a little bit of computing of things to add to our plot besides just the raw data, like trend lines, some summary statistics, and we're going to make multi-panel plots, and we're going to do at the end a little bit of changing up of the styling of the plots to make them look a little bit better than the default. Okay, so that's what we're going to do today. Let's start with just a very brief rundown of how ggplot, the sort of philosophical underpinnings of this plotting package. Well, there's a sort of graphic design, almost theoretician, who came up with this framework called the Grammar of Graphics, and that is what ggplot is based on, ggplot2. And the Grammar of Graphics, grammar, in other words, in linguistics, is kind of the way that different parts of speech are combined to make meaning. In the same way, we have variables in our data set that are mapped to graphical elements of a plot. So like, let's say you have a data set with age, weight, and sex, 3 columns, age, weight, and sex. Each row is an individual. Well, and you want to make a scatter plot. Each variable in your data is mapping to a certain aspect of the plot, a graphical aspect. Like age variable in the data is mapping to the x-axis, weight is mapping to the y-axis. Then you've got points, XY coordinates, and maybe sex. The sex variable maps to the color. You could pull out males in one color, females in another. that's the grammar of graphics. Not too complicated really once you learn what it is. And so here's some of the ggplot documentation has kind of a diagram of how this works. So you have the same building blocks make up every graph. The data, a coordinate system. So you have to have some two-dimensional area to plot on. And geoms are the visual components of the plot. And I guess that's short for geometry. I've never actually read the Grammar of Graphics book, but that's what I'm assuming. And yes, so a geom is any type of layer on the plot that's visually there. So like the layer of points would be a geom or a trend line or whatever. And the visual properties of that geom are called aesthetics, like the size, the color, and the location of the data are called aesthetics. So you map variables in the data to different aesthetic properties. So like the color would be, you know, the F column represents the color and the size is the A column. So like this, there's data in there in that like the color comes from a number in the data and the size of it does too. And this is how you actually make code out that implements the grammar of graphics. We're going to go through all this, so don't worry if it's confusing right now. Basically, they all start with the function ggplot. You have to say what data set you're using, obviously. That is required. You have to have some kind of geom to have something visual appear on the plot. And you have to have some kind of mapping, a way to know which variable in the data corresponds to what part of the plot. And then there are a bunch of optional things, and you always use the plus sign to add different elements of that together. You can change the coordinate system, facet to make multi-panel plots, scale to change the limits and scales on the axes and that kind of thing, and theme to change the appearance of the plot. If you don't put those, default will be used, but you can put them on any plot. What example data are we going to use in the lesson today? We've got 3 example data sets from Kaggle, which is kind of like a data science competition site where they post a bunch of data sets and then have people can analyze them, and they sometimes have competitions to see who can, you know, make the most predictive model from a certain data set. So I just pulled a few data sets off that to make plots with. One is like a survey, and if you go to the slides, I also link to the documentation for the data sets if you want to read more about them. One is the World Happiness Report, a survey of happiness levels in different countries and different variables about the countries. A big data set of breakfast cereal with some nutritional information on them. And a subset is a big data set, so I got only the subset of track and field medals from the Summer Olympics for over 100-year data set. That's what we're going to use. So let's load the, so in R, when you load a package that is a collection of functions that serve a common purpose, ggplot2 is a package, we're going to use the library function to load that package. Meaning installing a package is what you do once to get it on your system, and loading, every time you want to use that package, you have to just load it so that the functions are available in your environment to be used. We're going to just, that only package we're using here is ggplot2, and then we're going to read in the data sets. I put the data sets on this server, but even if you're not on the server, the data are posted on the GitHub site, where you can read in. The CSV files are imported into R as data frames directly from the URL. So the way that you, in RStudio, if you have a script open, if you put your cursor on a line and hit Control-Enter of the script, it will run that line of code in the console, which is where output also appears. If you want to run multiple lines at once, you can highlight a block of code with your mouse and then hit Control-Enter on that block of code, And so that's what I did there. And you can see that there's 3 data sets got imported in as 3 data frames: serial, Olympics, and World Happiness Report. You can click on this arrow to pull down the first few values of every column of the data set there. There's also, you could also go into your you can run code directly from the console as well. So like we could use the head function to look at the first few rows of a data frame down here. Like if we wanted to do head Olympics, type it in and hit enter. It shows the first few rows and all the columns of the Olympics data frame. So far, so good.
You can export out of Google itself.
Yes, you can. That's right. Yes, there's different options up here, and you could also use write CSV function there, which yes, that's definitely right. Okay, so we're first going to look at the World Happiness Report data set and explore whether money does indeed buy happiness. And so this data set, if you look at it here, let's just look at it the first few rows of this one as well, since that's the first one we're going to do. We'll use head parentheses WHR. Has to be all capitals because R is case sensitive, and the name of this data frame was the variable is in all capitals. You can see that if you look here, it has 156 rows and 13 columns. Each row is a country. So we've got the country's name, the region. Somehow they quantified based on a survey the happiness level of the population, which is the higher, the happier, going up to 7.587 for Switzerland, the world's happiest country. And at least at the time, I know I saw in the news just the other day that they put out a new version of this a few weeks ago, and the US dropped about 10 places in the happiness survey. I saw that headline the other day. So, you know, based on our current national malaise, you know, things aren't going, but we're still 23rd. Not terrible. I mean, there's a lot of sadder countries out there, so that's actually decent. But this is, I believe, 2015, so it's a little out of date. But and then we have some different standardized variables representing attributes of the country that we can then plot against happiness to see what predicts happiness. They're all standardized to some kind of meaningless number, but it's all just relative, like GDP, economic productivity, you know, family, life expectancy, freedom, a corruption index, that kind of thing. Okay, so we're going to, what we want to do here is plot, see if economic productivity as measured by GDP per capita on the x-axis is a good predictor of happiness score. So we'll do an X by Y scatter plot. And we're going to build this up little by little. All ggplots begin with the function ggplot, and all ggplots have to have a data set that you're plotting, at least one. So let's start by just doing that. So I left you some on line 25 here, some blanks. So we'll type in ggplot and then go over and get rid of these dots and replace it with WHR. And then you can press Control Enter to run that. Okay, so we get a gray rectangle if you did it right. And that's just what we were expecting because we've specified data, but we haven't specified a coordinate system and we haven't specified any visual layer to plot. So we get a blank plot. No surprise there. So what should we do next? Well, let's put in our coordinate system, which it automatically will do if you specify mapping of two aesthetic properties, which are the x-axis and the y-axis. So which columns of the data are going to map to those attributes of the plot? Well, you use the AES for aesthetic mapping function to do that as an additional argument to ggplot. So for X, we want GDP per capita, and for Y, we want happiness score. And those are the names of the columns as they appear in the data frame with the capitalization as it is there. So you'll need to type that in just as it appears. And you can always copy and paste it from the output here if you, it's also written on the next line down. So yes, GDP dot per dot capita with capital C, and happiness, also capital H, dot score, capital S. So we'll type that all in and hit Control Enter to run that. Okay, so now we get a little bit more. We have a coordinate system, and by default, it has set the upper and lower limits of it to encompass all the data in the data set with a little bit of padding on either side. But there's still no data plotted. And the reason is because we haven't added any geom layer, any visual layer that comes from the data. We just added a coordinate system, but no actual layer. So in ggplot, all additional components are combined by using the plus sign to add them together. And all the geom functions begin with geom underscore the name of the type of graphic that it is. And so geom underscore point is for a layer of points or a scatter plot. And it's a function. So we always had to put parentheses after it, although we're not supplying any non-default arguments to it right now. So let's do that. So I've given you everything except for the geom underscore point. Parentheses, Control Enter. Okay, so now we've actually, we're taking this at quite a slow pace. We've now made a scatter plot of an X variable by a Y variable. And, you know, though we haven't fit a formal model to it, the eyeball test says, well, clearly there's a very strong linearly increasing relationship and between economic output and happiness. There's not even any diminishing returns in this. It's just going up and up. So, you know, money is good. Yes, that's what. So we basically added the three non-optional elements, which are the data, mapping some of the columns to variables, and some kind of visual element. That's what you need to make a very simple plot. Any questions so far? Okay, so now let's keep everything the same, except we want the same data, the same mapping of variables in the data to elements of the plot, but a different visual element, which is the geom is going to change the geom line. And so let's, on line 31 here, instead of geom point, geom underscore line with parentheses, because we're calling a function. Control Enter. So you can see that geoms control how the data appear graphically, but it's still the same data. This doesn't really make sense for this data set because it's not, these are just independent samples from different countries. But if you had like a time series plot, you might want to plot it that way. Geom line does that. So that's just to illustrate everything about these two lines of code is the same except for geom point in one and geom line in the other. You can add multiple layers, multiple geoms to a plot. And let's do that. And geoms can also do computation on the data. It's not just the raw data they're plotting, like geom smooth being an example. It plots a smoothing trend line on the data, and it will overlay. And so point to make here is that geoms will be drawn in the order you add them. So the points will be drawn first, and then the smoothing line will go over that. If it covers up any points, you won't be able to see the points. And I also want to note here, I've split up the code onto 3 lines. That is not necessary, but it is a good practice, especially if you have a ggplot call with 10 or 12 lines on it. It makes it much easier to read than if it was all stretching out on one line. So if you end a line with a plus sign and hit enter, it will automatically indent the following line in a couple of spaces, but this will all be treated as one line when you run it. So let's do geom point and geom smooth, one after the other. Scroll down here. So first we want to do geom underscore point. The same, we're using, and by the way, if you start typing something, you can use a menu will drop down that you can use to complete the name of the function. So we'll use geom smooth. You can hit enter, and now we'll hit control enter somewhere on there. And you can see by default, when you do a geom smooth, it uses a low-S regression, which is like a locally weighted trend that will kind of fit some of the wiggles in the data. And it puts a standard error around it as well. So there you have it. And you can see it's more or less consistent with a straight line going up. So that's nice. Again, like this is something you'd use more for exploratory data analysis. If you were publishing this in a manuscript, I would want to have more control over the trend line I plotted and would actually fit a model separately and then plot it. But just for looking at the data, this is perfect to just like quickly throw a line on it. This is what more that's for, not necessarily. I wouldn't recommend throwing that into a paper as is, since you don't know what the parameters of the model is or anything like that. Yes, and as I just mentioned, it's a locally weighted regression with standard error. You can, if you just wanted to fit a linear least squares regression line that's straight with just a slope and intercept parameter, you can do that. Method is one of the arguments to geom smooth, and LM is the function in R for fitting a least squares linear regression, linear model, LM. So if we put method equals LM, we can make a straight line. And if for some reason you didn't want the shaded area for the standard error, which appears by default, SE equals false is how you would get rid of it. So let's do that. On the next block of code, we're going to do method equals LM and SE. I like to put spaces around my equal signs for supplying arguments. It's not necessary, but it makes the code more readable. False. So in R, the logical variables are always all in capitals. And control enter. So there we have a nice straight trend line, which still seems to be a pretty good fit, and no standard error of the fit. And let's now, the geom point has 2 required attributes, which are X and Y. You can't plot a scatter plot without having a coordinate system, but there are optional ones. Now, if you don't specify a color, it will plot them all in black. But let's say we wanted to map a variable in the data to color of the points, to color them by some grouping variable. Well, there's also a continent column in the data frame. Let's color the data points by continent. And let's see what happens when all this is the same as what we just did, except I added comma, color equals continent to the aesthetic mapping function. So that's what we're going to do. Color equals continent. It's capital C in the data. Control enter. And this is kind of nice because it does a lot of things for you automatically. It well, it colors the points by continent. It gives you a legend by default showing which continent they come from. Well, the Americas are lumped together. And it even, by default, if you did a trend line, it will by default group them and fit a separate linear trend line to each of the groups that are identified by the color, which is kind of neat. And we see that, you know, the slope is positive pretty much in all the continents, maybe, but it looks like the intercept is higher for the Americas. So for a given economic output, the Americas are happier than the other continents. So that's kind of nice. Okay, so that's how you would do that. And oh, just as you can see in this code right here, the AES is inside of the ggplot call, which means these mappings will be valid for every layer in the plot. But let's say we only wanted to map color to just one part of the plot, like we only wanted to color the points but not the line. Well, then you have to add the aesthetic mapping inside of that geom and then it will only apply to that geom. So like this is here, we put a separate aesthetic mapping inside of the geom point to color the points by continent, but it doesn't say color equals continent up here anymore. So the coloring and grouping will only apply to the points. The geom smooth will still be that same overall single line that we had 2 plots ago. So that just shows you that if you add AES to the entire plot, it will apply it to everything. But if you do it to one of the layers, it'll only apply to that layer. And so, yes, we put another AES call inside of geom point. And then we change this to color equals continent. And hit Control Enter. Oops. It's hard to do this from, well, anyway, that shouldn't be there. Yes, so now we have just our one trend line. Another, oh, I typed that in the wrong spot. That should have been there, but that's okay. The next thing to note is that you can put arguments to the geoms outside of the aesthetic mapping, and that will modify their appearance in just a way that is not reflect anything in the data. Like, let's say we just wanted to make all the points bigger. That is not referring back to anything in the data. We just want to make the points bigger to make the plot more readable. It has nothing to do with the data. We would put that outside of the aesthetic mapping and just add it as an argument directly to the geom point. So there's a parentheses closing out the AES function. Then we can add more arguments directly just to change the appearance however we want. Yes, you can. There is a argument. Well, we will get to that when we get to theme. Yes, you can. Oh yeah, so and then all these have defaults. So like size is an argument to geom point. By default, size equals 1. If we want to make them twice as big, you put size equals 2. And if you wanted to make the line black instead of blue, use a color equals black in quotes. Color names are character strings, so they're put in quotes. So that's how you do that. So we want that size equals 2. And color equals quote black. Control Enter. So now the points are a bit bigger and the line is black. Okay, so now we're going to do a little bit of theme stuff, which is changing the appearance of the plot. This is where you would change the font overall for the entire plot. It will change it. And we can add theme to the plot. I also want to show on this one, you see that you can, so far, all we've been doing is calling ggplot and it prints a plot to the plot window. But if you call ggplot and assign the result to a variable, then it will not print the plot. It will just store the plot in a variable that we can then later add more stuff to and then print it then. And that's also a good way to export plots to, we'll later go on how to export these to JPEGs and PDFs and stuff like that. That's also, you'd want to, instead of printing the plot in your window, you'd rather assign it to a variable and then export that to a file, which you then put in your manuscript or whatever. So we're gonna take the plot we just did, assign it to a variable, and then call that variable again with a new theme added to it. Theme underscore BW for black and white changes the overall theme of the plot. The default of ggplot, I never have understood this, is this gray with white lines on it, which, you know, is cool, I guess, but not the best for most presentations. I think it's kind of like their trademark, but I almost always get rid of that and replace it with black and white or something like that. So we'll assign this to a variable called happy. You can call it whatever you want, but it is called happy underscore GDP underscore plot in the next line. So you could just call it P and then, but I'm giving it a more descriptive name, which is a good practice. And then we'll add theme underscore BW. You can see a lot of theme options pop up, parentheses, and hit Control Enter. Well, we have to run this line of code first to create that variable. And you see nothing printed because we just created the variable. But now if I hit Control Enter, it will print and it looks exactly the same, except it has a different theme. You know, white background with black lines and a faint gray grid in the background.
So why do you assign it to a variable? Why do you need to do that?
In this case, you don't really need to, but it means we can now, I'm going to continue to use this same base plot with other things added to it. So I don't have to keep copying these same lines over to print it again. It's basically the entire structure of the plot is stored in this variable and can be added to and modified and later exported to a file and stuff like that. Yep. Yes. I mean, just for this right here, it's not necessary, but it will be later on. And there is a way, if you want to set a global theme default for all the plots you make in this current session of R from now on. It will change them all to that theme, which is called theme set. And so we never have to look at that ugly gray again. Let's go ahead and set the default theme to this black and white background. And so now all the plots we make from now on, unless we specify otherwise, will have that black and white theme. Yes, and that's sort of nice. If you like have a theme with a lot of arguments, you can set it to that. So then all the plots you make for like a manuscript look more or less the same style, which is nice.
You do all your things, because I have like a long list. I change every
Yes,
aspect of
yes, you could theme set that. Yep. And then all the plots you make would have that theme, and then you could modify it a little bit and by adding, you know, 1 or 2 elements to each plot, but you could have a base theme. Yep. So yes, if we run this line of code 63, nothing happens right now, but all subsequent plots we make will have theme BW without us having to type it every time. Well, there's also, so the theme BW is a base theme with a bunch of options, but here's where you would set specific things about the theme that you want to change in just the function theme does that. And let's say, okay, well, we're going to do a bunch of things here. We're going to, these are just some of the many options you can set. If we don't want those gray grid lines, we can get rid of them. Element blank means do not print anything for that theme element. So panel grid equals element blank means get rid of the grid. The legend is on the right side by default. We can move it to the bottom if we want to. And different text-based components of the plot are controlled by element text. We can change, some of them are, I think the axis text, like the numbers on the axis are gray by default. We can change it to black and make it a little bit bigger, 14 point. And we can make the titles, like the happiness score, the name of the axis, a boldface type. This is also where you would change the font as well. We can do that actually. I'll do that real quick to show you how. But let's do the ones that are on the script first. So element underscore blank means get rid of this. We don't want the background grid. The legend, we'll put bottom in quotes to put the legend on the bottom. This axis text, we wanted the color to be black, comma, size equals 14, a little bit bigger. And the axis title, we want the face to be bold. And the size to be also 14. And so, you can see we are adding all of this stuff to happy ggplot and assigning it back to that same object. So we're still not printing it. We are just assigning it to that object again. So we'll have it later. But now we can just type the name of the plot in and hit Control Enter, and it will print it. So we got rid of the grid, we moved the legend around, we changed up the numbers to make them bigger. And now I believe if you do, like, what if you wanted Times New Roman font, you would put family, the font family. Let's try it and see if it works. This is running on a Linux server. Windows is slightly different. You have to sort of use an extra function at the beginning to load a Windows font into R before you can use it. But I think on the Linux, it should just work like this. Let's just check that. We'll try it if we want to do Times New Roman font. Yeah, see, so now the labels are Times New Roman, but it only changed the axis title. The numbers are not, because we only specified that one to be Times New Roman. You can change the overall font as well in using the base family argument as well. And that will change all the things to that font. Any questions? But yeah, so if you're doing it on Windows, you have to use a function called Windows Fonts before you change the fonts, which will load. It'll go to the Windows font library, pull in a font, and then use it. I won't go into how to do that, but if you need help with it later, I can help. Yes, what's up? Let's have my teaching assistant help you out. I think I have a little bit more about this happiness plot. Once we do it, we'll take a 5-minute break and then do the next part of it after that. Here we'll give a second and get everyone caught up here. There's a lot of little syntax things. If one thing's in the wrong spot, yes. So another thing we haven't gone over yet is scales, and those modify ways in which the data are mapped to the graphics. Like if a variable in the data is mapped to the x-axis, we might want to change the range of the axis. We might want to change the breaks. Like, do we want a tick every 1 or every 2 units, and change the labels? Yes, you can do that as well. that might be in the theme part though. And or if a variable is mapped to color, you can change the colors that are being used to if you don't like the defaults. Because actually the defaults are not colorblind friendly necessarily. So usually if I'm going to put this in a manuscript, I would change it to one that has been verified to be discernible, even if you're red-green colorblind. I would recommend that for any manuscript where you put color and plot. And if you have a variable in the AES, you can add a scale for it. It's optional. So like in this, in the plot, we have X, Y, and color. We could add a scale for X, a scale for Y, or a scale for color, any of the three. Otherwise, a default is used. So let's just do X scale. So scale X continuous specifies that it is a scale for a continuous variable. We can name it. So it was called GDP dot per dot capita, but we can put a more readable name, and then breaks. If we want to say exactly where the ticks should go, we can put in a vector of breaks. So let's do that. And so the argument name will change the name, the title that will appear on here. And breaks, right now it's only 0, 0.5, 1, and 1.5. If we wanted to have it more finely spaced, we could do that. Hit Control Enter, and it runs, and now it has a nicer title and more ticks. We can also add a Y scale to it. Another argument is limits. Right now it goes from 3 to 7. If we wanted to add some more padding, we could make the limits 2 to 8, if that's what you want to do. And so the name, we can change it to happiness score without a dot in between, which is nicer to read. And we use the C function to create a vector 2, 8, meaning the min and the max of the limits. Control Enter. So it's just a little bit wider on the top and the bottom if that's what you wanted. And as I mentioned, we can add a third argument, which is the color scale. And Viridis is a color scale, one of several that can be distinguished by most colorblind people. Viridis D means discrete because we have 4 discrete categories instead of continuous. So we can change, yes, I've given you the code there, so you can just run that to see what it looks like. There are some different colors than the default. Okay, well, I think.
For example, I want to change it to red. Can I do that?
Yes, you can also, there's a lot of other color scales, and one, yeah, so, but usually if you put red and green in a plot together, that is not good for red-green colorblind unless they're different shades that can be told. But you can do scale color manual and specify any colors you want using the values argument. So we can put, R has a lot of color names. You can look up a chart of them. Like we would say forest green, brick red. I don't know, brick red is maybe not one. What is it? Well, we'll just put red. Slate blue and dark orange. Yeah, you can put whatever you want. But only certain. What I left out, the C there. You always had to put a C when you make a vector. And so there's that. You can put any customized one you want.
Can you take you see the function and you put on the down? Can you put that one up?
The legend, yes. So that would be to change the legend. You can put it on top, or you can put it inside the plot. And how you do that? Theme. We add a plus sign to add a new theme. Legend dot position, and you can put coordinates into an XY coordinate ranging from 0 to 1 to move the legend wherever you want. So we can say the legend will put the X at 0.1 and the Y at 0.9. So that'll be like somewhere in the upper left. Let's try that. Yep. So it cuts off. So you could tweak it and move it around a little bit. We could move it down to like 0.75 and see how that looks. Yeah, so you can put it right in there. Let's take a 5-minute break because it's now 10 o'clock and we're at kind of a good stopping point. So yeah, we'll come back at 10:06. No worries.
Yeah. You might want to plug in.
I can get you up there today, or maybe I can.
I just have to use the restroom. I'll be right back.
Yeah. Yeah.
That gives enough blood. Oh, this new building, they'll give us adequate plan.
Yeah.
Oh, the side, oh, the higher side. A lot of people can sit here, I mean.
Many people a lot of things. Yeah, as long as stays right here for 1%.
Control.
I'm not good. Stick my own any food table.
I'm working on the blocks, so next one is the most important.
The box plots.
Yeah. Stackable box.
Yeah. When did I know ggplot? I got a good default. There's nothing in the default. I like it.
Yeah.
It's like change every aspect of it. So my graph will be, each one address at 20 or 30 months. Straight. Which is nice how that's set, right?
Yeah.
Set some default ones, but I changed everything from
ggplot.
font size, font, I even Arial, but you know, the letter size,
Letter size.
font size, color, typograph, no grid lines, change how many font size looks at once.
Yeah.
The color schemes, all this stuff, I mean, how big the lines are around the bars, the color of the bar versus the fill, everything, I changed everything.
It makes me wonder why they pick such bad defaults.
I don't know, it.
There you go.
Like, put it in Excel.
That was the first.
Excel, it's the same thing, you have to change.
Yeah, so you have the blank plot.
Everything is, gets wrong.
Yeah, it's all wrong.
The X and Y variables.
I don't know,
So that's what was, they're just
turn it down, everything I like.
It doesn't do
it.
Was Rexford by the elevator?
Yeah, you have to go all the way down there to the stairs. Yep, and then turn right.
Thanks.
So on this one. Ooh, got it.
How's it going?
Going all right. Hey, do y'all need help getting set up there? Oh, he's got you? Okay, cool.
Oh, I figured out what was wrong with I was doing that. Some of the, that email I sent you,
Oh, yeah, the LS meetings thing.
yeah, for the Manova.
Uh-huh.
It turns out the variables,
So
had some
it has the
overlap.
data.
It didn't like that.
I see, okay.
So I guess I could just run them separately and just compare the F values.
I mean, yeah, it wouldn't, yes, if you're doing Manova, like basically it's not that different than doing them all individually. As long as you correct the p-value or doing a lot of multiple comparisons, you'd want to probably correct it across all of them.
Okay,
Yeah. So like using FDR correction or something.
well, I wasn't thinking about doing the, looking at the individuals, I was more interested in the differences in the group,
Right.
the F values. So for instance, then I wasn't interested so much in significance of F values, except maybe, but just like maybe difference between 2 or 3 different groups. And if this F value is larger than that. F
So
value-
you have data for a bunch of bands for like each genotype, basically, right?
Yeah,
And then they were done in different environments too.
yeah, and I just
Is
want to
it like
compare, like one measurement date was one day, one was another day.
I see. Okay, so you have different times too.
And then
for-
some
okay.
are different, and some of them were done a different day and a different kind of genotype, so
Okay,
there's some
okay.
compilation there.
Yes, it is gets confusing. Well, yeah, I mean, I'm happy to look at it too. If you want me to actually look at the data, I can.
And
Okay.
then the next one.
Yeah.
we'll do,
Hard to say, just, but yeah, I would say that
so
But would
next
F value be the
one-
best way to look at the magnitude?
Yeah.
That just a,
Yeah.
to look at,
like, for instance, if you want to say, I ran it once with this variable, and I ran it again with this.
Oh, I
variable,
see.
This F value is bigger than that value. They're both significant, then
well, like I said, I would rather use like some kind of mean squared error on cross validation to compare them. That's how I'd probably do it.
can you do that with the node?
Sure, you could, yeah. I mean, it's
It's just-
a model that
you were
makes
too- you were
predictions,
too
so
far.
anything that does that, you could do,
You can just click in here somewhere.
get a mean
Yeah.
squared error. Or you could do, yeah. Well, you could also get a AIC on the each Manova and use that to compare.
It's like a fit.
Yeah, so if adding
Smooth.
another variable improves the fit, then you can do it that way as well.
Yeah.
That's AIC is kind of like a shortcut of cross validation.
Yeah.
But yeah, it's just pretty much just, the variables are all convoluted, so I'd have to like run one with one model and then one with another.
Okay.
Another, and then say,
I
okay,
see.
this model had a bigger impact
Yeah.
than the other, something like.
Yeah, well, I can,
And then-
it's hard for me to think of it now, just not seeing
Yeah.
it, but I could definitely
And then in the next
take a
box,
look at
we
it
do
at some point if you want.
Okay.
Yeah,
do your errors.
Thanks.
sure.
And then we did all apps. Yeah.
Let's see.
Quentin, where do you find like the
So
different
then
themes,
this one, I
like
can
colors
do
and
this
stuff?
color.
Google is your friend there. There's a couple of packages that have, the package called SEE has a lot of extra color scales on it
Oh.
that have, yeah, those are really good. Yeah, if you like, if you just go into R and start typing like the name of like scale underscore color, it'll pop up all the ones that begin with that for that are loaded in any packages you have installed right now.
You would also, I just put it like ggplot color, and there's this one page, and it'll show lots of
Yep,
different, but I
yep.
put one line instead of doing sets manually.
Yeah,
I picked every color, and so you can do it, but it'll give you all the different ways. Something like red, or something like, it'll be like a pound sign and then a
Yeah,
code, lots
yes.
of those, and so you can do all the shades and.
you can.
Oh, wow.
Yes, so yeah, but I tend to like to use the C package has a couple of colorblind friendly ones that are nice to use. And Virid also is colorblind friendly, but it has like this bright yellow all the time, which I think looks ugly. So I try to like avoid the yellow.
And then the next one.
I guess yellow is like,
Color.
even colorblind people can see it, but it looks so bad in the plot
Yeah, it's
sometimes.
so white.
Yeah, I try to stick with like different shades of like blue, orange, and red and stuff, you know? Yeah, not as harsh on your eyes.
Yeah, and then just get rid of one here.
Yeah, it's weird how there's all these colors. I like to pick some kind of, you know, I don't know about control, but which one.
Yes,
But
sure,
you
sure.
can't really have any colors. It's
No,
incredible how quickly, you
yep.
really can't tell the difference, not like extremely quickly. I mean, of course, you can see shades if you're looking at them, but in a
Yep.
presentation or on paper. it's-
Yes, and then the next.
That's
one-
right.
Not too many colors you can have.
If you have more than 6 or 7, you should, you're probably plotting it wrong and should do it a different way because it's too hard to tell them. Yeah, that's a good point.
That's a big headache, you have a lot of different variables that you want to show.
Yes,
And basically, you start running out. of
Yeah,
colors.
you do, yes.
I found on like on a graph, if you want to pick different colors, you have,
Yeah,
you have
and then
more
control
than.
enter. And so now we have a new variable. that are-
Three and six, you're gonna really be difficult at telling which one's which, and, you know. Really affect it, I don't know, I just find.
All right.
And then
So,
get rid of the plus dot. Here.
And you can do like different, like you want
Each
set of colors, you can make it different shapes too.
yes, you can. Yeah, so you could like,
And then we're gonna get rid of the gray back.
the shapes are done in like a numerical code. So you have to like, let's see, well, yeah, if you went up here and
to view
where we had the geom point. Let's see, you can do like shape.
the grid. I guess you
Here, we'll do it up here, like,
can view a-
Okay.
if like, I don't know, I forget which one, like shape equals 3, what does that do?
And then legend down position, put it bottom.
Yeah, so like there's different shapes, and you could also make the shape, you could also have the shape change by continent too, if you did it this way.
And then put in size equals 14.
Then it's gonna have 4 different shapes too. And if you don't like those shapes, you would add a scale shape manual and change the shapes from those to different ones. Yep, it's done the exact same way as color. Yep. So yeah, that's always a way to like also make it colorblind accessible, is doing shapes too. Yep. Yep.
And then one, yeah. flash.
Hey, I'm sorry that I didn't realize that you weren't able to follow along at first. I'm sorry, you should have said something sooner. Okay. Okay. Well, shall we move on with this, and then hopefully we're now all on the same page close enough. So let's keep going, and now we've sort of done scatter plots. That was the first one, so it took the longest. We'll kind of go through some other plot types a bit, just to give you a bit of a survey of what's out there. Let's say right, so the scatter plot was good for 2 continuous variables. Let's say we have 1 continuous variable and some kind of category like a treatment or whatever. And you want to visualize the distribution of the data. A decent way to do that is the box plot, the Tukey's box plot, which shows you the median, the central 50% of the data as a box, and then whiskers to show sort of where the extreme values are, and any outliers are plotted as points on top of that. And so continent, let's say you want to do this by continent. Our X variable is a category continent, discrete variable, and our Y variable is a continuous happiness score. We can put those as our AES mappings, and then add geom underscore box plot to make a separate box plot for each of those 4, for each of the categories, for each of the 4 continents in the data set. So let's do that. I scrolled up here. So let's see, we're about at line 90. Your lines may have changed a little if you entered in anything, but we're about where it says box plots as a comment in the code. So we're going to do X equals continent now, not color anymore, comma, Y equals happiness period score. Again, you don't need spaces around the equal sign, but it's more readable to put them. And then we have to have at least 1 geom, and here we're going to do geom underscore box plot. And once you hit Control Enter on that, you'll see some box plots. So there are the distribution of happiness scores for the 4 continent regions that were in the data set. That's how you do a box plot. Simple enough. Now I'll just show you a few ways to spice it up by changing the appearance of the box plot. That's really all there is to it. Now, scatter plots have a color variable. Box plots also have a fill variable. Anytime in ggplot it says color, that means the color of points or lines. Anytime you're coloring in an area, you use fill. That's what the name of the graphical element for filling in areas with color. And fill, color, and size is the line thickness of the box plot. The default is 1, I think. So if we put size 1.5, it'll make the lines a bit thicker. So again, we're changing no aesthetic mapping. We're only adding optional elements to the geom box plot to change the overall appearance of the plot. We're not changing any data related mappings right here. We just wanted to make it 4 is green inside, and the lines be a dark gray. Gray 25 is sort of 25% away from all black, and make the lines a bit thicker. Just as an option, you could obviously do it any way you want. So fill in with 4 is green. Change the colors from black to kind of a darkish gray. I don't know why you'd want to do that, but it's just an example. And make the lines a bit thicker. Then you get that. Super. So that should be pretty straightforward. There's even box plots, plot every point that's outside of 1.5 times the interquartile range away. Those are those whiskers. Anything outside of that is considered an outlier and is plotted as a separate point. You can change the size of them with outlier size. Oh, and alpha is a parameter that shows how much transparency something has. Alpha equals 1 is completely opaque. Alpha equals 0 is completely transparent. So you could make, if some of the outliers are overlapping on each other, you can make them semi-transparent, and then it will show where the points are overlapping on each other. If we wanted to make them 70% transparent, for example, we could put 0.7 in for that. Outlier.size to make them bigger, and outlier.alpha to make them see, because here you see that a couple points are overlapping on each other. That's why I sometimes like to make them semi-transparent so that you could see how many points are overplotted. Outlier.size equals 2 to make them bigger. Outlier.alpha equals 0.7 to make them semi-transparent. So the plot is exactly the same, except actually, yeah, did the points get bigger? I'm not sure, but well, let's make them even bigger. Let's make it up to 3. Yeah, so they're a little bigger, and you can see where some are overlapping. So that's neat. So those are like some countries that are especially happy in Africa. It'd be interesting to go in and look at what those ones are in the data. So that was box plots. I didn't go into it too much, but it just to show you that they're there and you can do stuff with them. But they're a very great kind of plot. So, you know, the humble box plot doesn't get the respect it deserves, I think, but it should. So we're going to spend a while looking at histograms now, or density plots. Now, these are usually for the it's univariate plot. We only have one, really, we don't have an XY coordinate. We have one variable that has a distribution, and we want to look at how the data are distributed. So you only put X into a histogram. You do not need to put Y, because the Y-axis is computed from the data. The heights of the different bins of the histogram are actually computed from the data. It is not a column in your data set. The X is the only thing you need to put. And ggplot will compute that Y value for you. So we're going to go away from happiness for a minute, and now we're going to go to serial. And this is yeah, well, let's just out of curiosity, let's look at the, oh, by the way, if you double click on a data set up here in the environment pane, it will pop up a sort of spreadsheet like window that you can actually scroll through it. So you got, you know, your all brand, Apple Jacks, Cap'n Crunch, Corn Pops, all that good stuff that I was never allowed to have when I was a kid, which is probably good thing. And we mostly had Cheerios and Kicks at home. Yeah, so that's your cereal. And they've got calories and per serving, you know, all that kind of stuff. And so we want to look at a distribution of grams of sugar per serving of cereal. So we just have to say, what is the data set? Cereal. What variable in the data is mapping? Is just one, the X variable. Sugars is the name of it. And what kind of geom will be used? Geom underscore histogram. That's it. That's all you need to make a basic histogram. Just an X. X equals, oops. Yeah, X equals sugars. And we just had to put a geom histogram. Control Enter. And there you have, it bins them up because there's 77 rows in the data set. And you can see the Y-axis goes up to about 12 or 13 in each bin, going from Apparently there's some negative sugar values and going all the way up to 15. I can't vouch for the integrity of the data set, but that seems like there's something wrong with that. But it's kind of like how celery has negative calories because the energy you take to chew it is more than is inside of it. Maybe that's it. Well, and oh, you notice that it gives you a default, a little, it's not a error, it's just a message. Stat bin using bins equals 30. By default, it's using 30 bins, but maybe since there's only 77 rows in the data, 30 bins is kind of too many because a lot of them have 0 values in them. So it looks like a gap tooth histogram. We can change that default. You can either use bin width to say how wide each bin will be, or use bins to say how many it will be. And so we can put bins equals 10, which is maybe a little bit more appropriate. There's like algorithms also you can use to choose the bin width, but I won't get into that right now. We'll just say 10, just using our judgment. So that's maybe a little bit better illustration of the distribution. It's kind of almost like a bimodal distribution. You have your healthy cereals and your, yummy cereals up there, very sugary ones. Yep, so that's the distribution of sugar as a histogram. And I want to also point out something that I always change on ggplots. You can see that ggplot always puts this little gap of padding underneath the bottom of the lowest variable data point on each axis. Like there's always a little padding around all sides of it. That's very good for something like a scatter plot. You don't want the point to be right on the edge. It's good to have a little padding, but I don't think it looks very good for bar plots and histograms where you'd kind of want 0 to be at the bottom because then it looks like the bar is floating. And often I want to get rid of that. So I wanted to show y'all how to get rid of it. If you want to get rid of the little gap, well, we have to add a special modified y-axis scale and use the argument expand to turn off the padding on the bottom, but keep a little padding on top. And we say expansion parentheses add equals C 0, 1. That means we want 0 units of padding under and 1 unit of padding at the top. So there's still a little padding above at the upper end of the y-axis. That's how you'd get rid of that, because the axis is in sort of integer units. So adding 1 unit at the top would be a good amount to add. So we have to add scale underscore y underscore continuous because it is a numeric axis. And other than that, everything is the same. It's still geom histogram with 10 bins. If you hit Control Enter, it's exactly the same, except the padding, the bars are not floating in the air anymore, which is nice. So I always do that when I make the histograms, get rid of that padding underneath. Any questions? So going back to the slides, what if we wanted to change the color that the histogram bars are? They're kind of a dark gray by default. Well, let's make them slate blue, which is a nice blue color. So we add a fill argument to geom histogram. It is not inside of an aesthetic mapping because it's just our personal taste. We're not going back to the data to change this. We just want it to be blue just cause. And at the same time, I also want to illustrate how to put titles and subtitles on your ggplots. The function ggtitle is used for that. The first argument is a title, and the second argument, if you put a comma and another character string, would be a subtitle that appears smaller underneath. So distribution of grams of sugar per serving, and underneath they'll say for 77 brands of breakfast cereal. We're going to take all of that and assign it to a variable called sugar hist, which we'll modify some more later. So yes, I'm showing you how to change the fill color and put title and subtitle on the plot here in our next step. And you don't have to put slate blue. You can put any color you want. I just like slate blue better than blue just because blue is just like this oversaturated blue that's kind of ugly, but slate blue is a little bit calmer, easier on the eyes. And then we have a GG title I've given you. So we hit Control Enter there. It doesn't print anything because we've just assigned it to a variable. But then if we type the name of the plot in and run that again, it will give our title and subtitle and fill in. Aaliyah, do you have a question? Grant, do you mind helping her out? Thanks. Let's see. So that was that. And another nice function is a shortcut function called labs for labels. If you want to change the name of one of the axes without having to add a full specification for the axis, you can do labs or labs, and you can put X equals whatever you want, comma Y, all the different axes and titles. You can you can change here. So if you wanted it right now, it just says sugars, or no, it says count. Oh no, I'm sorry. Yeah, sugars is the X-axis is what we're changing, but the units on that is grams per serving. We might want to put the units, so we can add a this labs function with a argument X equals the name of the X-axis. And so, that's kind of nice. So that was histograms. Moving right along to an alternative for univariate data visualization. Instead of plotting binned histogram, would be a smooth kernel density plot, which is kind of empirically fitting a distribution, a density function. Density function being a function that integrates to one, showing where how the data are distributed. And that's a statistical computation that has to be done. So it uses a function that begins with stat instead of geom, stat underscore density. It computes a summary statistic or a summary function based on the data and plots it. So stat underscore density. And I decided to just do calories instead of sugars this time, just to show another variable, but we still have cereal being our data set. Calories is the variable, just one, because it's univariate. And stat underscore density is the thing we are plotting. So let's see what that looks like by default. And then we'll kind of modify it a bit to make it look better. So we want calories. Stat underscore density. Control Enter. So there's a density plot of the calorie distribution. So it uses an algorithm, just like the histogram has to be done with a certain number of bins. The density is fitted with it. First, you use an algorithm to select the kernel bandwidth. So like, how wiggly will this line be? How closely will it fit the data? And so that gives you a density plot. Well, that doesn't look that good because it's kind of too wiggly, I think. So you can tweak that bandwidth parameter that the density smoothing algorithm is choosing for you by using the adjust argument. The default is 1, meaning we'll multiply the bandwidth that the algorithm chooses by 1. We're not going to change it. Any adjust above 1 will make a smoother curve that fits the data less closely and has less gaps in it. If you make a adjust between 0 and 1, it'll make an even wigglier line than we have already. So let's try 2 to make it a little bit smoother. So we're doing everything the same, except we're going to put adjust equals 2 on this line here. Control Enter to run. So now we just have a bit of a smoother line. It looks somewhat bell curve like. Maybe has different tails than a normal distribution would have, but that's a slightly smooth density function. Another thing you can do is, instead of having a filled in area for the density function, you can just have a line. And so you can change what geom is being used to show this computed density function. If you put geom equals line in quotes, the default is polygon. It'll be a filled in area. We can change it to line if we want to. So that's line in quotes. It's a character string. Control Enter. Same thing, except it's a line instead of a polygon, which maybe saves ink on your printer. So that's nice. And this maybe if you don't want to follow along on everything, that's okay. But I just wanted to show some common ways you might want to adjust a kernel density plot to make it look nicer. If you want to change the line width to make it thicker, you can change the color of the line. Those would be within the stat density call. We can add X and Y scales and change the padding. We can say the multiplicative padding is 0 at the bottom of the y-axis and 2% at the top. It'll add a little bit of padding. On the x-axis, we don't want any padding on either side. And we can change the title of it and add a title and subtitle to the plot as well. Those are just some things you might want to do to the density plot. I see I've left a lot of blank spaces in there for you. So yes, if you want to make the line thicker, you put line width. The default is actually a little bit less than 1, I believe. It's like 0.75. So 1.2 will make a pretty thick line. And yes, you can do your scale underscore y underscore continuous. We will use the expand argument to change the padding and the expansion function to do that. And mult is what we'll use for multiplicative instead of additive. We can multiply the limits by a certain amount instead of adding. There's 2 ways to do it. And you can use scale x continuous to do your x scale. Again, we'll use expand, but we don't want any padding because sometimes I don't like to have this like gap here on either side, so you can get rid of it. And GG title to change the title and subtitle of the plot. So there's just I think it slightly improves the look of it to have no gap on either side there. So that's that. We basically have one more type of one more example data set we're going to go through. Then I just have some examples of add-ons at the end that we're not going to walk through the code for. So we'll spend a few minutes going through this last example, and then we'll have plenty of time after for office hour kind of stuff. This is, okay, so I really wanted to cover facets in this because I think facets is the most powerful aspect of ggplot, and it's what really makes it a lot better than the base R plotting functions and a lot of other plotting packages. You can very easily group your data and create multiple panel figures from different groups in the data without having to write each code for each plot separately. So we're going to take this Olympics data set. Let's look again at the Olympics data set. If you double click on Olympics over here, you can see we got the year each Olympic was held. I'm giving you track and field, athletics, the name of the athlete, their country, whether it was men or women event, what event it was, 100-meter dash, and Francis Lane got the bronze medal in 1896. All the way up to, I guess, 2012 Olympics. Let's see how far up it goes. Yeah, 2012 London Olympics. Okay, so first of all, so we can close that now that you've seen it. Well, this, just run this code here to make a subset of the Olympics data set with just 4 countries. The United States, Great Britain, Russia, or the Soviet Union, I guess, for most of the time. And then I put Jamaica in there as well because they're such an overachieving track and field nation. And it's quite impressive how that small country has racked up so many medals over the years, thanks to the likes of Usain Bolt and his country people. So yeah, we're just going to pull those 4 countries out so we can plot each one as separate panels. So let's, before we separate out it by country, let's show how you would make a bar plot showing counts in each category of something. This is, we want to say, okay, medal is the X axis, that's gold, silver, and bronze medals. And then we can make a bar plot showing the counts within each category. Stat equals count means we're going to take all the times it says gold, count them up and make a bar. All the times it says silver, all the times it says bronze, count them up and make a bar out of it. G on bar is what does that. And so we want our AES. What are we going to map? We're going to make X equals medal. We're going to take the medal variable and put it on the X axis. And we want G on bar stat equals count. We want a count of each type of medal as a separate bar. Control Enter. So there it shows how many bronze, silver, and gold medals. I'm not sure why they're not all the exact same number, because there should have been one for every event, but that's the data we have. Yes, do you have a question? Grant, can you help her out? Thank you. I appreciate that. So this plot is not very informative. What we really wanted to do was plot the medal totals for each country separately. So let's show how you would make a separate panel for each of the 4 countries in our data set and plot the medal counts for each country. We would use a facet for that. Facet being a separate panel with a group of the data. And facet underscore wrap is what you use to make a separate plot for different groups in your data. Remember, there was a column called country in the data. So we're going to facet wrap and the tilde meaning by to make a separate plot for each country, and facet wrap meaning it will wrap onto multiple rows of plots if it doesn't all fit in one row. So we're going to do that. Facet underscore wrap by country, with otherwise the plot being the same as previous. Facet underscore wrap by country with a capital C. Control Enter. And so yeah, by default, it makes a separate panel for each one with the name of the country code at the top. USA is crushing it in the track and field medals. But you know, we see the other ones aren't far behind. And this is so that's, and another thing you note is that it will by default give the same maximum value on the y-axis for all 4 panels, even if the scale of the data is very different. You can modify that so that each row of plots has its own y-axis limit, so that you can see, don't have to worry about some of them not being visible. And we can make all of them have their own limits by free underscore y, which will make the y-axis variable between the plots. You can do x also, or scales equals free would make them both be different. But we're just going to change. The only thing we're going to add here is scales equals free underscore y, which will make the y-axis different on each, I guess on each facet separately. So we want, in quotes, free underscore y, which will free the y-axis to vary by plot. So now you can see that the Jamaican one only goes up to 50 there. So far, so good. Yes, you can't make any tiny mistake, otherwise nothing will work. Not very forgiving. There's another facet function called facet grid. If we want to make, right now, what we have is just a different panel for each country, and it wraps onto multiple rows to make a 2x2. But what if we wanted to separate this by men's and women's events? We can show the medal tally for each combination of country and gender in a 4x2 grid. And so we use the facet grid function for that. Country by, this tilde means by, gender. So the country will be going down the rows and gender across the columns for a 4x2 grid of plots. That's the and we're still going to let the y-axis be variable, so we still have the free y. Facet underscore grid instead of facet wrap now. And country tilde, that's your upper left hand of the keyboard, gender, country by gender. Control enter. So now you can see the different medal tallies. You can see Jamaica female athletes are relatively good compared to their male athletes. The US has gotten a lot more medals in men's events over the years, you know, if that's something you're into. Now, here's something that often comes up. The order in which categorical variables plot on a plot is alphabetical by default. That may not be what you want. Like if your control group you wanted to put first or something, it might not be alphabetically first. In order to change the way it appears on the plot, you have to change the underlying data to order the variables as a factor so that it goes in the order you want. Like in alphabetical order, bronze, gold, silver, but really we might want bronze, silver, gold to show it in a more logical order for the Olympics. Well, you have to make the medal variable in the data set into a factor and specify the ordering of the levels. So I've given you the code to do that. We basically say factor this medal variable and make the levels bronze, comma, silver, comma, gold. And then I'm going to plot with the exact same code we used before. That's exactly the same as we just did. So we haven't changed anything about the plot code, just changed the data. Underlying data is actually going to be different to change the order of the plotting. So I've given you that code without any blanks to fill in, just to show you how that works. Control enter there, and then control enter there. Now the plot is the same data, except it goes bronze, silver, gold every time. Everyone understand? I believe this is our last one that we're actually going to fill in data or fill in code. Then I'll show you how to write plots to files. Then I'm just going to give you like a 5-minute just demo of some of the other things you can do with ggplot without you having to write any more code. So this is the last part of code you'll actually have to write. We're getting close to the end here. So this is just like, okay, let's kind of like spice up this medal plot and make it look cool. Well, so the first 3 lines are the same as before. Oh, except that we're adding, just for the heck of it, we wanted to make the bars bronze, silver, and gold. Let's say you wanted to do that. Well, now X, the medal variable is not only mapping to the X, it's also mapping to the fill. It's the same column in the data is mapping to 2 different aspects of the plot. So it's kind of redundant, but it's for the look of the plot. We can map medal to X and fill so that the bars will be filled based on the type of medal it is. I put a title and subtitle on the plot. I've added a y-axis with no padding at the bottom, some padding at the top, so it doesn't look like the bars are floating. And this is where I've added the manual scale. Since we've been talking about doing manual colors, scale fill manual means I can specify any colors I want. And it turns out that these chocolate 4, gray 60, and golden rod look kind of like bronze, silver, and gold. So that's what I chose to use. And I've named each one to match up with the appropriate column. And I've added some theme elements, no legend, because we don't really need a legend to show the colors because the colors already have names underneath the axis. And then a couple of arguments to make the plot, the background of the little titles not be gray and not have a background grid because it's not really needed. So that's what all of that does. That's just, those are all optional, but just to show you ways in which we could improve the look of the plot. So let's go through and what did let's see, GG title is the one where we're going to add a title. And you can also specify subtitle for the second argument, just so it's clear that's the subtitle. We want to change the padding of the y-axis. So that's scale underscore y underscore continuous. And we want to do a manual setting of the fill colors. So that's scale underscore fill underscore manual, using the values argument to set what the values are of it. And then some theme elements as well. If we run that, you know, that looks kind of cool. And I've cited the Guardian, which is where the data set comes from. Yeah, so that's sort of neat. Now, the last thing before we do the little demo of cool add-ons of ggplot is the ggsave function. This is a really important one because it's how you write a ggplot to a file, which you can put in a document, and it automatically determines the file type based on whatever extension you put here. Like you could put JPG for JPEG, PDF, it will write it to that format. And it automatically determines an appropriate size of the image and resolution for you, but you can specify them. ggsave, and I've put it in the working directory in a subdirectory called plots. If you're on the Posit Cloud, I've made this folder called plots for you. That's if you're on your own machine, you could either make a directory called plots or you could just delete where it says plots and it would just save it to the current directory. So let's try to do it. Just save that sugar hiss that we made a while ago. Let's write it to a file. If we hit Control Enter, let's see, cannot find, should be. I see they've changed the way they did the cloud server since we last did this. We can create a directory. I see it should be in home and not project. Well, why don't we, well, we'll just do it like that for now. So it will actually prompt you to create a directory. If we go to home, this temporary directory, plots, there's the file. We can open it. There it is. I'll have to, yeah. So, and then this just shows you some other ways you can modify the appearance of it. You can change the resolution to 400 DPI using the DPI argument. You can say 4 for the height and 4 for the width. By default, it'll do it in inches. If you don't specify a unit, it just inches. And oh yeah, it automatically saved 5 by 2.69 inches image, but I don't know how it exactly picks those defaults. But if you want to do 4 by 4, you could do it this way. So now we've overwritten that. If you look at it, it's got a different shape to it now, 4 by 4. Oh, and you can specify the units as centimeters. If you journals sometimes have requirements of like in inches or centimeters or whatever. So you can say 9 by 9 centimeters. I won't run that because it won't really be any different. And see, look, if I put PDF instead of PNG, it will automatically create a PDF file. And PDF does not have a resolution because it is vector graphics. So you just put the dimensions of the PDF and it will write it to a PDF.
Is there a list of all different kinds of formats?
If you look at the documentation, some of it depends on your system as
Yeah,
well.
I just tried one that said it was missing a tag.
Yes, so you might have to install some, what was that?
SVG.
Yeah, so you should be able to install whatever packages it recommends to do that. But yeah, if you go to GG save documentation, yeah, so here it lists out the formats that it supports. It should be anything you would need there.
Yeah, on Linux, I think you have to install the SVG system library.
But it's Windows, it looks like it's on there. It says
Yeah.
Windows only, so I think it has all of those.
Or yeah, well, WMF is the one that's Windows only, but SVG, yeah, if you're doing it on the POSIT server, I don't really know how to do SVGs from there, but we can figure it out
Yeah,
later on if you need it.
Very bad.
Yep.
I'm curious.
So yes, if we do PDF on it instead, you can see it made a PDF. And we can, yeah, so it's just in a PDF instead now.
Also remember depending on the dimensions, will mess with everything you did, changing, like, for instance, the font size and everything in the graph.
Yep,
You change the dimensions and it's gonna mess with all that, so you have
That's
to
right.
coordinate with that.
that's right, because the
So
font size is absolute, it's like 14 point. If you made this 10 by 10 inches, that would be very tiny, but if it's a 4 by 4, the 14 point will be big, so yes.
There's no relative function where you.
It doesn't- I mean, then you would just like, you can, there is ways to do that, but probably the easiest is just like to make a high resolution image, a resolution high enough that you can then scale it bigger and it'll still look good if you just like scale the image later on. Yeah, so, oh, and also I just want to point out, if you do not specify a ggplot object in the argument here in ggsave, it'll take whatever the last plot you created and save it. So that's that. If you don't specify this, it'll just take the last plot you wrote and save it. So make sure you know what you're saving. Yeah, so that's yep, we just went through that. And yes, that's all that I just said. Well, just as a ending teaser for you, I want to show that ggplot itself does not support every type of plot you might want to make, especially maps. There's a bunch of add-on packages that allow you to make really nice maps with sort of base ggplot underlying it. I won't get into that here, but basically, since R is open source and anybody can contribute a package, there's like a whole ecosystem, if you will, of packages people have written as add-ons to ggplot that will that let you make cool plots. So I just have a few examples of those to show you what kind of stuff you could do. GG themes is a package which has a bunch of themes that are not included in base ggplot2. So like if you wanted to make a plot that looked kind of like the graphs they put in the magazine The Economist, it has a GG themes has a function called theme economist. Well, if we wanted to do our sugar histogram like that, well, we'll have to load the GG themes package. Yeah, so this all, you don't have to run this code yourself if you don't want to. I'm just showing you. We can do the sugar histogram. That looks kind of like it was in The Economist because they always have this like certain background and the font they use and stuff like that. 538, which I think doesn't exist anymore, but or it got bought out by ABC and is not what it used to be, but used to have good stats and data articles, but it's kind of gone downhill lately. But that's what their graphs look like. Edward Tufte is like this famous sort of graphic visualization thinker, I guess, and he has his own ideas about how graphs should look, and that's how, in his personal style, that histogram would look. He doesn't like excess lines, so you see it's just little ticks with no lines. Another one I want to show is GG highlight. And remember how when we looked at that happiness plot, we said, oh, I wonder what those like especially happy countries are. Well, GG highlight can actually take a scatter plot And based on certain conditions, like let's say we wanted to highlight any country with really low happiness of less than 3 or above 7.5, it will label the countries and highlight those points. So I've given, and you can set the size of the label and what text will appear there. So if we run that happiness scatter plot, you can see it grays out everything except for the ones we want to highlight and shows like what the names of the countries are that are above or below a certain happiness level, which is sort of neat.
Can you use that in the box plot for the outliers?
Yes, I'm sure you could. I haven't tested it, but I'm sure you could.
Oh, yeah.
And I mean, certainly like if it wasn't available in GG highlight, you could probably manually write code to do that, but I bet you could. Yeah. We can like try to play with it later if you want. And then the last one I wanted to show was ggplot2, which at least claims to give you publication worthy graphs, which a lot of times people want to put asterisks separating means that have a p-value that's significantly different. It allows you to do that. Like let's say we did a statistical test that showed that Europe and Africa had significantly different happiness and the Americas and Africa had significantly different happiness. I won't go into the code, but this is how you would make lines connecting them with an asterisk showing this, that those pairs of means are significantly different. So it gives you, it kind of makes some neat things like a box plot with the raw data superimposed and then lines connecting. Actually, I think if you zoom in, it will look a little bit better. Yes, it shows up better on this. Oh yeah, whenever you click zoom, it'll pop out a window. So you can see like, okay, hypothetically, we did a stat test showing those means were significantly different. You can make something like that pretty easily with ggplot2.
I guess you could put like A and B and C.
You can, yes. It would also, and that can be done without any add-on packages. You can do that by adding a geom text layer to your ggplot, which is what I usually do for that. Yes, if you want that alphabet soup, that is how you get it.
I thought that was necessary for being an agricultural site.
Yes, you have to have those letters. Yes, I always like so the letters are a nice shortcut, but they're not everything, but they can be a nice shortcut to, yeah. So that's all I have for, we actually end up taking 2 hours, but that's okay because we still have 1 hour till lunch. So we now have an hour I can answer whatever questions you have about this or anything related to our stats, data, life advice. I'm here for you. So yeah, that's I'll stop recording the meeting here and later on I can post that the recording.
I think that the best program to detect a line is jump. Because in jump, you can go there, take it, and one click, you will see which cell has the outlier.